Up until now, we've been organizing and summarizing our data using tables and graphs. Today, we'll talk about numerical summaries. These are single numbers that tell us something about our data. And you're already familiar with a numerical summary. On your transcript, when you graduate, it's going to contain all the classes you've taken along with all the grades that you've gotten, a lot of data. It also contains a numerical summary. That's your GPA. Your GPA is a single number that summarizes your entire academic career. Today, we'll talk about numerical summaries, single numbers, that will tell us something about the center of the data. First measure of center I want to talk about is called the mean. The mean is really just the average. Here we have exam scores, 78, 83, 92, 68, 85. What would be the mean here? What would be the average? And how do you find it? To find the average, or the mean, what we do is we'll add up all the data values and then divide by however many data values we have. So first thing we'll do is we'll add up all the data values. So 78 plus 83 plus 92 plus 68 plus 85. And then divided by however many data values we have. So how many data values do we have? 1, 2, 3, 4, 5. So on my calculator, up top, 78 plus 83 plus 92 plus 68 plus 85. On the bottom, 5. 81.2. So if you're using the decimal scientific calculator, you can just enter it directly, exactly like you see it here. If you're using another calculator, you probably would have to add up the top first, get an answer, and then divide by 5. The next measure of center is the median, and the median just means the middle number. After you put the data in order first. So the first thing we need to do is put the data in order. First example here, negative 20, 15, 21, negative 20, 19. First thing I'll do is put the data in order from smallest to largest. So smallest would be what? Negative 20. And then I have another negative 20. What's next? 15. 19, and then the 21. Put the data in order. Once you have the data in order, the median is just a number that's in the middle of the list. And here, the number in the middle of my list is the 15. So 15 is the median. Let's try one more example. 28, negative 31, 28, 10, 31, negative 23. First thing we'll do, put the data in order. So in order, what goes first? Negative 31. Next up would be the negative 23. Okay, that takes care of all my negative numbers. Next up will be the 10. I have two 28s next. And then finally, I have a positive 31. Now, what's the difference between A and B? In A, notice that we had 1, 2, 3, 4, 5 data values, an odd number of data values. When you have an odd number of data values, there is going to be a number right smack in the middle, and that's your median. In part B, notice that we have 1, 2, 3, 4, 5, 6 data values. When you have an even number of data values, there's not going to be a single number in the middle. Okay, notice that it's not going to be 10, right? Because there's 2 numbers below and 3 above. It's not going to be 28 because we have 3 numbers below and 2 above. So there's not a number right smack in the middle. When you have an even number of data values, you take the 2 in the middle. So the 2 in the middle here are the 10 and 28. And then you're just going to take the average of those 2 in the middle. So 10 and 28, the average, add them up, divide by 2. So 10 plus 28 up top, divided by 2, 19. Okay, if you're using another calculator, you might have to do 10 plus 28 first, get an answer, and then divide by 2. 19 is our median. Okay, and the significance of the median is because it's the middle number, about half of our data is above and half of it is below. So 15, notice that there's 2 data values above and 2 below. 19 is our median in the second example. Notice that there are 1, 2, 3, 28, 28, 31. So there's 3 data values above, and then below it are 10, negative 23, negative 31. So 3 above and 3 below. So same number above, same number below. So when you hear a professor say the median on a test is 80, what that means is that about half of the class got better than 80 and half of the class got below 80. The last measure center is the mode. And the mode is the number that occurs most frequently. It's the data value that occurs the most often. Part A, if I look at my data values here, which one occurs the most often? Look at the 1. The 1 occurs 1, 2, 3, 4 times. Okay? All of the other numbers occur only once. So 1 is the mode. Part B, which one occurs most often? Notice that here there's a tie. The 4 occurs 2 times, the 6 occurs 2 times, and then everything else occurred once. So when you have ties like this, both of those numbers are the modes. So here we have 2 modes, 4 and 6. But if everything is tied, like in the last example here, 4, 8, 5, 9, 6, 3, notice that everything only occurred once, so everything is tied with occurring once. So if everything is tied, there's no mode. On the first page, we saw how to find the mean, the median, and the mode. Now, everything you saw on that first page was how to find those things if you were given the original raw data. Now, oftentimes you don't have the original raw data, and you're given something like a table like we do here, or a graph like a histogram. And the question is, how do you find the mean, median, and mode if you're given a table like this one? And the idea is we need to somehow go backwards and recover the original raw data. Once we have the original raw data, we can find the mean, median, and mode the same way we did it on that first page. Example 1 here, we have a table for ungrouped data. And all that means is that we're not breaking up the data into ranges like we are in example 2. In example 2, we have a table for group data, and notice that we're breaking up the data into ranges. Let's go back to example 1. A group of people were asked how many siblings they have. The data is summarized below. The idea, like I said before, is in order to find a mean, median, mode, we have to go back to the original raw data. And the question is, what is this table telling me about the original raw data? What does the 6 mean? The 6 means that there are 6 people who said that they have 0 siblings. There's 11 people who said that they have 1 sibling. There's 7 people who had 2 siblings and 4 people who had 3 siblings. That means that in my original data, I have 6 zeros. I have 11 ones, 7 twos, 4 threes. So let me write all that out. So in my original data, I should have 6 zeros. Okay, those are my 6 zeros. Let me just keep track that there's 6 of those. There's 11 ones. There's 7 twos. and then there's 4 threes. And that's my original data. Once I have my original data, I can find the mean, the median, and the mode the same way we found it on the first page. To find the mean, add up all of your data values and then divide by however many data values you have. So let's be smart about this. To add up the data values, you could go 0 plus 0 plus 0 plus 0 plus 0 6 times. But that's the same thing as saying 0 times 6. Right? 0 times 6 means 0 plus 0 plus 0 6 times. You could add up 1 plus 1 plus 1 plus 1 11 times. But that's the same thing as saying 1 times 11. You could go 2 plus 2 plus 2 plus 2 7 times. That's the same thing as saying 2 times 7. And then finally, 3 plus 3 plus 3 plus 3 is the same thing as saying 3 4 times, or times 4. Okay, so the top, I added up all my data values, and now we need to divide by however many data values we have. Now you could also count 1, 2, 3, 4, 5 all the way to the end, but an easier way is to use these numbers, right? This 6 means that there's 6 of these, there's 11 of these 1s, there's 7 of these 2s, and 4 of these 3s, which means all I need to do is add up these frequencies, and that should tell me how many data values I have in my data set. So add up the frequencies, 6 plus 11 plus 7 plus 4. And now let's enter this into a calculator. So I recommend using the Desmos Scientific Calculator and just enter it exactly like you see it here. Fraction up top, 0 times 6 plus 1 times 11 plus 2 times 7 plus 2 times 4. On the bottom, 6 plus 11 plus 7 plus 4. Rounded to 3 decimal places, I'm getting 1.321. If you're using another calculator where you can't enter a fraction like this, do the top separately, get a number. Do the bottom separately, get a number, and then divide. Now, next up is the median. The median is the middle number. Remember, put your data values in order. It's already in order, so all my zeros, all my ones, all my twos, all my threes, and then we want to find the middle number. Now, either there's a number right smack in the middle, or if you end up with 2 numbers in the middle, you'll find the average of those 2 numbers. So what I like to do is, it's kind of long, but I'm just going to go one at a time from the beginning and the end and work my way to the middle. Okay, so I'll go beginning, end, 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 until you either get to 1 number in the middle or 2 numbers in the middle. Here we have 2 numbers in the middle. They're both 1s. So if you have 2 numbers in the middle, you will average those 2 numbers. So we'll average the 2 numbers in the middle, which is add them up, divide by 2. So 1 plus 1 over 2. And I don't need a calculator for this because I know that's going to be 2 over 2, which is 1. And that's the median. Finally, the mode. The mode is the number that occurs most frequently. If I look at my data, the number that occurs most frequently is the 1s. Right? The 1s occur 11 times. So my mode is 1. You can also get the mode from looking at just the table at the beginning. That's the easiest one to find. Just look for the highest frequency highest frequency here is 11, which means the mode is the 1. In example 2, we have a table for group data. So group data just means that we're breaking up the data into ranges like this. So frequency distribution below summarizes employee years of service for a certain company. Now the problem with group data is that, what does this 5 mean? This 5 means that there's 5 people who have between 1 and 7 years of service. So we don't actually know what the raw data is. All I know is that there's 5 people somewhere between 1 and 7. I actually don't know what those actual numbers are. I just know that they're between 1 and 7. Which is why, if you have group data, the best we can do is approximate. Okay? And here's how we're going to approximate. We're going to find the midpoints. And just as a reminder, the way you find midpoints is, the formula is lower plus next lower divided by 2. Okay, so that means that the low number plus the next lower number, 8 divided by 2. So our first midpoint will be 1 plus 8 divided by 2. So type in exactly like you see it on your calculator. Up top, 1 plus 8. On the bottom, 2. 4.5. Okay, that's the midpoint that goes with the first range. If you're not using the decimal scientific calculator, make sure you're doing 1 plus 8 first, which you'll get 9, and then 9 divided by 2, and you'll get 4.5. The next midpoint will be 8 plus 15 divided by 2. Okay, 8 plus 15 on top, 2 on bottom, 11.5. Now let me remind you the shortcut for getting the rest of the midpoints. Find a class width. Okay, look at my lowers. 1 to 8, 8 to 15, 15 to 22. How much are these numbers going up by? So 1 to 8, that's going up by how much? 7, right? So you can just say 8 minus 1, that's 7. You can do 15 minus 8, that's 7. So all my lower numbers are going up by 7. All my upper numbers are also going up by 7, which means all my midpoints will also go up by 7. And it is, right? It's 4, 4.5, 11.5. That's 7 away, okay? So all we need to do is just keep on adding 7s, and we'll get the rest of the midpoints. So 11.5 plus 7, that's 18.5. 18.5 plus 7, 25.5. And that's my midpoints. So here's where the approximation comes in. I know there's 5 people who have somewhere between 1 and 7 years of service. Okay? I don't know what those actual numbers are. I just know that they're somewhere between 1 and 7. So the approximation is, we're just going to assume that all 5 numbers are the midpoint. All 8 numbers are 11.5. All 12 numbers are 18.5, and so on. So now, let's write out the original data. So there are 5 people. We're going to assume that they're all 4.5, which means in my original data, there's going to be 5 4.5s. 4.5, 4.5. And there's 5 of those. There's 8 11.5s. One, two, three, four, five, six. 2 more. There's 12 18.5s. So this one's long. It's 1, 2, 3, 4, 5, 6. Let me go to the next line. There's 12 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 6 25.5s. So my original data, so ignore these frequencies, my original data is right here. Once I have my original data, I can find the mean, the median, and the mode the same way we found it on the first page. To find the mean, add up all of the data values, and we're going to use multiplication to help us add. So instead of doing 4.5 plus 4.5 plus 4.5 5 times, we just do 4.5 times 5. Instead of doing 11.5 plus 11.5 plus 11.5 8 times, we can just do 11.5 times 8. Instead of doing 18.5 plus 18.5 plus 18.5 12 times, we'll just do 18.5 times 12. And then 25.5 6 times, or times 6. Okay, so the top, we added up all of our data values. For the bottom, divide by however many data values we have. And remember, the easy way to do it is just to add up your frequencies, because there's 5 of these, there's 8 of these, 12 of these, 6 of these. So if you just add up the frequencies, that should give you the total number of data values. So 5 plus 8 plus 12 plus 6. And now let's go to a calculator and enter this. So enter it exactly like you see it. Up top, 4.5 times 5 plus 11.5 times 8 plus 18.5 times 12 plus 25.5 times 6. And the bottom, 5 plus 8 plus 12 plus 6. Round to 3 decimal places, I'm getting 15.790. The median, okay, put your data values in order. It's already in order, right? 4.5s, 11.5s, 18.5s, 25.5s. And then we want to find the middle number. Either the middle number right smack in the middle, if it's a single number, or take the 2 numbers in the middle and average those. And I'm going to do this kind of the long way by just going from the front and from the back and kind of work my way to the middle. Now, later on, we'll talk about a formula that will get you directly to the middle, but for now, just go from the front and the back, okay? 1 in front, 1 from the back, 1 from the front, 1 from the back, 1 from the front, from the back, front, 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 back. Okay, there is a single number right smack in the middle. That's our median. If you end up with 2 numbers in the middle, you'll just average those 2 numbers. And then finally, the mode. The mode is easy. The mode is just the number that occurs most frequently. If I look at my data here, the one that occurs most frequently is this 18.5, which occurred 12 times. 18.5 is the mode. Example 3. So we're given a histogram and we're asked to find the mean, the median, and the mode. How do you do this? Well, the previous 2 examples, we already talked about how to find the mean, median, and mode from a table. So the idea here is go from your histogram to a table. Once you have your table, just do it like example 2 and example 1. So let's make a table. Now notice that in this histogram, right, this is the situation with the group data because each bar is over a range, which means my table should have ranges. And also remember that on a histogram, the numbers on the bottom, when you have group data, the numbers on the bottom are the lower limits. Which means these numbers, 15, 30, 45, 60, 75, and 90, should be the lower number in each range. So my ranges should be 15 to something, 30 to something, 45 to something, 60 to something, 75 to something, and 90 to something. And actually, I probably won't even need the 90. Now, the upper numbers, so this first upper number should be the number that's slightly below 30 or just below 30, which is 29. And then you can use however many decimals you want. Because we don't have the original data here, you can use 1 decimal or 2 decimals or 3 decimals. It's up to you. So 29.9 or 29.99 or 29.999 or even more than that. The next upper should be just below 45, which is 44.9. I'll just use 1 decimal. Next one should be just below 60, which is 59.9. The next one just below the 74 or 75, which is 74.9. This one just below the 90, 89.9. And then we probably don't even need this last one, but if you needed it, how would you find it? Well, find the class width. So my lowers are going up by how many? If I just look at these two, 45 to 60, that's going up by how many? 60 minus 45, that's 15. So that means that my class width is 15. All of my lower numbers are going up by 15, which means all my upper numbers need to go up by 15 also. To find this last one, just add 15 to this 89.9. Which is 104.9. And now the frequencies. This is a frequency histogram, which means the heights of the bars are the actual frequencies. 12 is the frequency for 15 to just before 30. So 15 to 29.9, frequency is 12. 30 to just before 45, frequency is 3. 4, 3, and then finally 2 is the frequency for 75 to just before 90. That's 2. And then, like I said, we didn't actually need this one anyway. And that's a frequency table. Once you have this table, this is a table of the type that we saw in example 2, okay, well, for group data. And to find the mean, the median, and the mode, you just do exactly what we did in example 2. So I won't do it here, but that's the idea. Now that we know how to compute the mean, the median, and the mode, let's talk about some of their properties. First thing I want to talk about here is I have two sets of numbers, 3, 10, 18, 25, 50. Let me actually find the mean and the median for the first set here. And let me actually just tell you the answers. 3, 10, 18, 25, 50, I would tell you that if you were to compute it, the mean is 21.2. The median, the numbers are already in order. So the median is just the number in the middle. In this case, there's a number right smack in the middle. It's 18. Now, the second set of numbers are the same numbers except I changed the 50 and switched it out with a 371. So a number that is way bigger compared to the rest of the data. That's called an extreme value. Extreme values are just numbers that are data values that are either way big or way small compared to the rest of your data. Okay, so 371 is way bigger than these other numbers, 310, 18, 25. And now let me do the same thing. Find the mean and find the median. And I will tell you that the mean is 85.4 and the median, the numbers are in order still. So the median is the number right smack in the middle, which is still 18. So compare the first set with the second set. So first set, second set, all I did was I replaced one of the numbers with an extreme value. What changed more, the mean or the median? The median actually stayed the same, right? 18, 18. The mean went from 21.2 all the way up to 85.4. So the point I want to make here is that when you have extreme values, the extreme values affect the mean more than the median. Okay, that's the point I want to make here. So the mean is affected by extreme values. The median is not affected. And I should actually say not affected as much. So now let's talk about the mean, the median, and the shape of data. So by shape of data, I mean skewed left, skewed right, symmetric. The first picture, is that skewed left or skewed right? Skewness, remember, has to do with the location of the tail. I have a peak here. This part is the tail. The tail is on the right side. This is skewed right. And what I want to show you with this picture is that when you have data skewed right, so what that means is that most of your data is where the peak is. So most of your data is on the low side. Then you have a few data on the high side. So you have a few extreme values on the high side. The extreme values will affect the mean more, like we said up here, and it does it by pulling the mean towards the extreme values. So what happens is in skewed right, most of your data is low, and then you have a few extreme values on the high side. The extreme values will pull the mean upward towards it, which is why you get the mean to the right of the median. Okay, so when data is skewed right, the mean is to the right of the median. Skewed right, the mean is to the right. Picture on the end here, the tail is on the left side. This is skewed left. Skewed left data means most of your data is high and you have a few extreme values on the low side. The extreme values affect the mean more, and it affects it by pulling the mean towards it. So extreme values on the low side, it will pull the mean downward, which will make the mean to the left of the median. Okay, skewed left, the mean is going to be to the left of the median. And then the picture in the middle, this is symmetric. When data is symmetric, the mean and the median are about the same. So now let's try an example. Actually, before we try an example, one thing I want to say here is that because the mean is affected by extreme values, if your data has extreme values, it's better to use the median than the mean. because the median is not going to be affected much by those extreme values. If you look at income in a certain city or housing prices in a certain city, you will find extreme values, right? Income, most people make around a certain range, and then you have a few people who make millions of dollars a year, right? Those are extreme values. Same thing with housing prices. Most of the housing prices are around the same amount, and then you have those giant mansions which are millions of dollars. Those are extreme values. That's why when we talk about income or housing prices, you will see people use the median more often than the mean because of those extreme values. Back to example 4. Here we have a histogram, and we're asked to pick out the mean and the median from these choices. So here's the strat. First, is this picture skewed left or skewed right? So skewness refers to the location of the tail. Here's the tail. It's on the left side. This is skewed left. And what do we know about skewed left? If it's skewed left, the mean should be to the left of the median. So I'm expecting the mean to be to the left of the median. In other words, to the left meaning it should be less. So I'm expecting the mean to be less than the median. That should allow you to eliminate 2 of these choices. So I'm expecting the mean to be less than the median. B is no good, right? B, mean 5.4, median 4.6. I expect the mean to be less than the median. B is no good. Same thing with C. Mean 6.2, median 6.1. The mean should be to the left or less than the median. That's not the case for C. So C is no good. So now we're down to 2 choices. To pick between these choices, look at the mean on both of them. So here, part A, mean is 5.9. D, mean is 4.2. Now, the other fact that you need is, do playgrounds have seesaws anymore? If you go to a playground, do you see this thing anymore? The seesaw where you have 2 people on 2 ends and they go up and down. That's a seesaw. Okay, imagine the histogram, these bars on a histogram as blocks of wood. And imagine them on a seesaw. This thing here, I think it's called a fulcrum. That's not how you spell fulcrum. I hope that's how you spell fulcrum. But this thing, that's the fulcrum. The mean is where you should put the fulcrum so that this plank of wood, this bar, is balanced. Okay? Now, the way I have it set up, one of these will definitely not balance. Eliminate that one, and whatever's left is the answer. Okay. Let's try this 4.2. So mean 4.2. If I place the fulcrum at 4.2, here's 0, 1, 2, 3, 4.2 will be right here. Would this thing tip over or would it be balanced? If I put the fulcrum at 4.2, it would definitely tip over, right? Because I have like 1, 2, 3 big bars on the right side. And on the left side, I have 1, 2, 3, 4, but they're all small bars. So it would definitely tip over on the right side, which means 4.2 is no good. The answer is going to be A. At 5.9, which is right here, it has a better chance of balancing, right? Because I have 2 big blocks on the right side, but on the left side, I have smaller blocks, but I have more of them. So there's a better chance of balancing at this 5.9, right? The mean is the location where this will balance. All right, let's try the next one. First thing I want to ask myself is this picture skewed left or skewed right? That's the tail. Skewed right. It's on the right side, which means this is skewed right. And what do we know about skewed right? Skewed right, the mean should be to the right of the median. Being to the right means being bigger. So the mean should be bigger than the median. Now, you should be able to eliminate two of these because the mean is not to the right of the median. So which two can we get rid of? I can get rid of B, right? Because B is 2.1, 2.3. The mean is to the left. So B is no good. Which other one can I eliminate? D, right? D, 3.2, 4.2. Mean is 3.2. That would be to the left of the median. I want it to the right. So D is no good. Now, of what's left, look at the mean. Okay, and imagine these blocks on a plank of wood on a seesaw. The mean should be the location where it's balanced. Okay, one of these should obviously not balance. So let's try both of them. 4.2. 4.2 is right here. Would that balance? Okay, imagine this as a plank of wood. If you were to hold it here, say with your hand or your finger, would it balance or would it tip over? It would tip over, right? I have a whole bunch of big blocks on the left side, not a lot of small blocks on the right side. It's going to tip over this way, which means 4.2 is no good. The answer would have to be C. And at 2.2, which is right here, it has a better chance of balancing. I have like two big blocks on the left side. On the right side, I have smaller blocks, but I have more of them. So we have a better chance of balancing here at 2.2. A lot of small blocks has a better chance of balancing the two big blocks on the left. Example 5. A report states that the mean household income last year for a certain city was $50,100 and the median was $39,500. If a histogram were constructed for the incomes of all households in the county, would you expect it to be skewed right, skewed left, or approximately symmetric? For these questions, we're going to use what we know about the skewness and the location of the mean, whether it's to the left or to the right of the median. What I recommend is make a number line and put whatever number I give you on that number line. So the numbers I need to put on here are 50,100 and 39,500. The one on the left should be the smaller one, which is 39,500. And the one on the right is 50,100. Because on the number line, bigger numbers are to the right. 39,500. What is this? Is this the mean or is this the median? Median was 39,500. This is the median. Which means 50,100 is the mean. Now, what do I know about location of the mean and skewedness? I know that if it's skewed right, the mean should be to the right of the median. If it's skewed left, the mean is to the left of the median. What is it in this case? Where's the mean? Is the mean to the left or to the right of the median? The mean is to the right, which means the histogram would be skewed right. So this is going to be skewed right. Because the mean is to the right of the median. Example 6. In a study of Facebook users conducted in 2012 by the Pew Research Center, the mean number of Facebook friends per user was 245. If the data is skewed left, would you expect the median to be greater than 245, less than 245, or approximately equal to 245? Make my number line. The only number I gave you here was the 245, so I'll just put 245 somewhere. Now, what is this 245? Is it the mean? Is it the median? The mean number of Facebook friends was 245. This 245 is the mean. If data is skewed left, okay, so that's important. So I'm telling you that the data is skewed left. And what do I know about data that's skewed left? I know that skewed left means that the mean is to the left of the median. So what I'm saying here is that the mean should be to the left. So what this skewed left part is telling me is that the mean should be to the left. Right? Because it's skewed left. And then the question is, where would you put the median? Here or here, so that the mean is to the left of the median? Would you put it here or would you put it here? You can't put the median here. If you put the median here, then the mean will be on the right side of the median, but we want it to the left. You would have to put the median right here. Okay? If I put the median right here, then the mean is to the left of the median, like I want it. And what does this mean? Median, is it greater than 245, less than 245, or equal to 245? Well, the median is to the right, and to the right means bigger. The median will be bigger than 245. Example 7. According to the National Vital Statistics reports, the median life expectancy in the United States was 83.5. If data is skewed left, would you expect the mean to be greater than, less than, or approximately equal to 83.5? Make my number line. I only gave you one number, which is the 83.5, so I'll put it somewhere. And what is this thing? Is this a median or is this a mean? Median life expectancy was 83.5. It is the median. I'm also told that the data is skewed left. Okay, that's important. What do I know about skewed left data? Skewed left, the mean is to the left. Okay, so this is telling me that the mean should be to the left of the median. And now the question is, where should you put the mean? Here or here, so that it is to the left of the median? Well, you would put it right here. Okay, if I do that, then the mean is to the left of the median, exactly like I want it. And now what does this mean? This means that the mean is less than, because it's to the left. So being to the left means you're less than. The mean is less than 83.5. That's all I have for you today. Have a great day. See you next time.